Suppose you have two lines in the plane. What can happen if you have two lines in the plane? Well, there are three possibilities. You might have the two lines crossing each other and giving you a single intersection. So in this case, they will intersect. Or they could be just going in the same direction and they might never meet. In this case, they would be parallel. And a third case is that you might have the two lines to be exactly on top of each other. So in this case, they could be coincidental. Or another intuitive way of its describing it would be overlapping. Now what you need to know is that in this case, the two graphs have different slopes. So distinct slope. But over here, these have the same slope. And the distinction between these two can be described in terms not of the lines but about the equation. So these lines will have their describing equations, right? You know the line equations for these lines. So if the two lines are distinct in their slope, we say the equations are independent. And if they have the same slope, we say the equations are dependent. Then even when it has same slope, we know that there are two cases, right? So if it's parallel, that means there's only there isn't any point of intersection, so no intersection. And in that case, if you write down the system of equations for both, there's no x and y that will satisfy both equations, because if there was one, then the two lines should be meeting at that point, but as you can see in the graph there, they never intersect, right? So if they have no intersection, then we say that the equations are inconsistent because it's impossible to find two variables x and y, two numbers x and y that would satisfy it. Okay. And on the other hand, when they're coincidental, then there are infinitely many solutions, infinitely many intersections, because every point on the lines are just intersecting with the other line, right? And in this case, we say the equations are consistent. Okay. All right, so let me try to explain that by using some examples. So here are three systems, and I intentionally made the first equation look the same so that I can reduce my computation. But to see if whether they are intersecting at a point or not, we should find the slopes. By the way, you really want to know this before you solve a system of equations, because what if they have the same slope? Then you immediately know that the two equations will never meet, meaning that the solution doesn't exist, or they might be overlapping, in which case you have infinitely many solutions and you can't find a single solution. So it's important to check this before you solve a system of equations. Or you can just proceed to try to solve the equations, and then you're going to find out that you might have a solution, or in which case they're intersecting, or they might give you contradiction, in which case they might be parallel, and so on and so on. So there are different strategies. Okay, anyways, let's try to find the slope. I subtract 3x both sides, so it's 2y equals to negative 3x plus 7. And dividing by 2, you get y equals to negative 3 over 2x plus 7 over 2. So we know that this is the slope, and this is the y-intercept. What about this? Well, subtract 6x again, negative 2y equals to negative 6x plus 9. Divide by negative 2 both sides. So these cancel and you just get y. And this can be split into two fractions like that, right? So negative 6 divided by negative 2, negative negative becomes positive. 6 divided by 2 gives you 3. So you have 3x. And 9 divided by negative 2, that's negative 9 over 2. So we have the slope as 3, and because this slope is different from negative 3 over 2, we know that the two lines are not parallel nor overlapping, so they must be intersecting at a single point. So the conclusion after this is that these intersect, and the two equations are independent. Okay, so these are the two conclusions you can make after figuring out their slope and y-intercept. Okay, now let's try to do this. I already know that this is this one. I'm using the same equation, so I know that the slope is negative 3 over 2 and y-intercept is 7 over 2. What about this? Let's try to compute this. This is, if you subtract 6x both sides, then 4y is equal to negative 6x plus 9. Dividing by 4 gives you y equals to negative 6 over 4x plus 9 over 4, because it does this, right? And then 6 and 4 are both divisible by 2, so you can rewrite this as negative 3 over 2. And now I see that the slope, negative 3 over 2, is exactly the same as the slope of the top one. So that means, since the slopes are the same, either these two equations or the two lines are parallel or they're overlapping. How do you know which is which? Well, that's when you look at the y-intercept, because if two lines are overlapping, then they must have the same y-intercept, right? But here I see that the y-intercept for the second one is 9 over 4, and that's not the same as 7 over 2. So two y-intercepts are different while slopes are equal. So what does that mean? That means that the two lines are parallel. In this case, you cannot expect any intersection, meaning that x and y that satisfy both equations do not exist. So in this case, we say the equations are inconsistent. Okay. All right, let's look at this last one. Now this thing, don't be fooled by what it looks like. Negative 2/3 is not the slope. It's actually, you have to solve for y. This is solved for x, right? So let's just multiply by 3, because I'm not so comfortable with denominators. If I multiply by 3, you get 3x. 3 times denominator 3 cancels, and you just get negative 2y. And 3 and 3 again cancels, and you just get 7. And if you move the negative 2y to the left, you get 3x plus 2y equals to 7. And what do you find? These two are identical, right? So what you thought were two equations describing two different lines, I see that after transforming one of them, they are exactly the same equation. In this case, the two are coincidental. So coincidental lines, and equations are consistent. but there's no hope of finding a single solution here because the lines just overlap. So any pair of numbers that satisfies the first equation will automatically satisfy the second equation because they are indeed just the same thing. So in this case, we say the equations are consistent.